So looking at the question, we know that there's 18 dominoes tiles, and there's only one way she wins, if she guesses exactly what it is. There's 17 ways she loses, because there's 17 ways she would not guess what it is. So there's a 1 out of 18 chance that she picks the right thing. Now they want me to try this 1 out of 18 probability thing 2,250 times, 2,250 times. So they want me to bubble this up to say, what if she tries it 2,250 times? We're supposed to figure out how many times then it's going to work. Well, if we take a look at the denominators of the now proportion I have set up, I'm saying, what number would I multiply by 18 to get to 2,250? Well, that actually is something we can find, because we know that 18 times 125 is 2,250. So the same multiplier has to work in the bottom, that I'm multiplying by 125. So when I take 1 and multiply it by 125, I get my answer, which is 125. So it will work 125 times when she tries it 2,250 times. Notice the way I set up my proportion. We know probability is always how many times it wins or works, or whatever you want me to say, compared to the total number of possibilities. So originally, with 18 times, it worked one way. Here, 2,250 different tries, here's how many times it worked. Both of these numbers on the bottom represent the total number of possibilities. That's why they're both in the bottom. We know when we talked about proportions, we can't mix and match. We have to be unit consistent. If what's in the bottom represents the total number of times it works once, or the total number of possibilities, it's always got to be the total number of possibilities. If what the top represents is the number of winning scenarios or the number of times it works, that's always got to be in the top. That's why my proportion is written the way it is. Number 2. In a new game, 2 players each flip a coin. Player A wins if at least one of the 2 coins is heads. Otherwise, B wins. Determine whether or not the game is fair. So we know from our earlier question, our results are heads and tails, heads and heads, tails and heads, tails and tails. Now we're saying player A wins if one of the options is heads. Doesn't say exactly 1 like it did earlier, it says just 1. So here's one that has at least 1 heads, here's another one that has at least 1 heads, here's another one that has at least 1 heads. So there's 3 options that win for A out of 4 possible. B wins any other scenario. Well, there's only one that works for B, still out of 4 options. Well, because these guys are not the same, that means the game is not fair.